basics of geospatial data. So you have data models like a data model is a set of rules and or constructs used to describe and represent aspects of the real world in a computer. So there are two primary data models in geospatial, and the first one is raster data model, and the second one is vector data model. So the raster data model is widely used in applications ranging from far beyond geographic information system. The file formats such as JPEG, BMP, and TIFF, etc. are based on the raster data model. So for example, we have this image here, and this when you zoom in, you get the pixels the image starts to get distorted, and you start to see the pixels of that specific image. So that is what raster represents. The raster data models consist of rows and columns of equally sized pixels interconnected to form a planar surface. These pixels are used as building blocks for creating points, lines, networks, and surfaces. So you can see this image from USGS, and it shows the common raster graphics used in GIS applications. So you can see we have a raster image here, and we can convert these to lines and points, so to vector data. Okay, so raster data model is known as grid-based system due to its dependence on a consistent set of square pixels. Each grid location will normally be assigned a single data value. The feature of the spatial phenomena at a location indicated by its row and column is represented by the single value carried by each cell in a raster. That cell value's data type can be either floating point or integer. So thank you. Now let us talk about another type of data model, which is vector data model. Use points and their associated XY coordinates, that's latitude and longitude, pairs to represent the vertices of spatial features, much as if they were being drawn on a map. So this was by Aronoff 1989 for geographic information systems and a management perspective. So data attributes of these features are then stored in a separate database management system. The spatial information and the attribute information for these models are linked via a simple identification number, that's an ID, that is given to each feature in a map. There are three fundamental vector data types that exist in geographic information systems, and these are points, which are zero-dimensional objects that contain only a single coordinate pair. So if we have like XY, single point XY, points are typically used to model singular discrete features such as buildings, wells, power poles, sample locations, and so forth. So points have only the property of location, that is latitude and longitude. Other types of point features include the node and vertex. Specifically, a point is a standalone feature, while a node is a topological junction representing a common XY coordinate pair between intersecting lines and or polygons. So vertices are defined as each bend along a line or polygon feature that is not the intersection of lines or polygons. Yeah, so a single point, like kind of a dot, but it has X and Y coordinates. The next one is lines, which are one-dimensional features composed of multiple explicitly connected points. Lines are used to represent linear features such as roads, streams, faults, boundaries, and so forth. Lines have the property of length. So more than one point, we get a line. So if we have XY, X1, Y1, and X2, Y2, when we join those points, we get a line. Lines directly connect two nodes are sometimes referred to as chains, edges, segments, or arcs. The next one is polygons. These are two-dimensional features created by multiple lines. that loop back to create a closed feature. So let's say, for example, we said one point is xy, 2 points x1, y1, x2, y2. When you join them together, we get a line. And when we get another point, x1, y1, x2, y2, and x3, y3, when we join those 3 points, we get a polygon, which is a two-dimensional feature on a map. So in the case of polygons, the first coordinate pair point on the first line segment is the same as the last coordinate pair on the last line segment. So we say x1, y1, x2, y2, x3, y3. When we join those, it means we are going to enclose. If we began at x1, y1, we go to x2, y2, x3, y3, and then back to x1, y1. That means we have closed the point. So polygons are used to represent features such as city boundaries, geological formations, lakes, soils, associations, vegetation, communities, and so forth. Polygons are the properties of area and have the properties of area and perimeter. Polygons are also called areas. So an enclosed surface is a polygon. So this is an example of a combination of both points, lines, and polygons to form a vector data model. You can see the lines here. So these are lines. These are polygons. You can see the enclosed polygons or some kind of regular shapes. Then these are the points. So the dot points with a single x and y coordinate. So thank you for watching, and I will see you in the next one.